So I will talk about catching hackers with Koney. This talk is by me, but the tool that I'm going to show you, which we open sourced this April, was actually co-developed with Matteo, which I want to give a huge shout out here as well. So briefly to me, I do research on these kinds of topics, cloud security, Kubernetes, containers, both at Dynatrace Research and also at the Johannes Kepler University in Linz. As an introduction to set the stage here today, imagine that an attacker infiltrated your cluster, already breached all your other intrusion detection systems that you might have, and they already have access to your file system right now. So they might start looking around, they might go certain places. Few things that we could try. Maybe let's look at the home directory. Nothing interesting here. Maybe the bash history. Let's see what commands were there placed by an admin before us. Who knows this path here? Run secrets. I expected more hands. You should notice if you work with Kubernetes, this is the place where often like tokens, service accounts are mounted. So we see here the one for Kubernetes. And if I were a hacker, I would look for those. So, for example, here's the Kubernetes service account that I could use to run certain things on behalf of on behalf of this service's identity. But there's another one. Who knows .aws credentials? That gives you a lot of access in your AWS cluster. And if I see this in a pod, very interesting, I would definitely try this out. Although this was just a trap. And this was just a trap. So if you are in the place of an attacker and you're just looking around, touching those files, you might come across also certain sensitive secrets that we only place there to deceive you. So this is the concept of cyber deception. And we assume that attackers progress in stages. And why don't we also set up traps throughout those stages? So the AWS credentials is one of those traps. And I don't mean honeypots here. I mean traps like Honeytokens, so the files that you saw, fake endpoints, or other kinds of deceptive content. This slows down the attackers because they waste time with those kinds of resources. And it also assists defenders because it typically gives you a strong indicator of compromise if someone trips over your trap. They might like browse that path, open that file. So if you probably are familiar with honeypots, but not many people are with Honeytokens. Just one more metaphor to that. So if I don't want thieves to steal my bike, I could place honeypots, which would be fake bikes, which would then also kind of protect my bike. But the idea of Honeytokens instead is we want to integrate small traps directly into your applications. Like I'm really talking about production systems possibly here. And this is what this talk will be about here. So this is the concept in the academic scene. We often say application layer cyber deception. It could be files that we place in file systems. It could be new HTTP endpoints like a /admin that was not there before. We could even modify version numbers in HTTP headers, have or even like modify entire HTTP bodies. And the problem with all of these is they sound nice and cool, and especially like in theory, you can talk a lot about them, but it's really hard to embed them into your applications. And even more so because software, typically the people that write the software, then they give you like a container image or something. There's another kind of people that deploy that. And sometimes there's even a third persona that needs to defend this and secure this. So to integrate these traps, though, we would need the developers. And instead, we want to give the administrators, the system operators, a tool to help them add those kinds of traps on the fly at runtime in Kubernetes. So this is why we came up with Koney. It's open source on GitHub here. So You should hear me better now. Great. Thank you. So the idea is here that instead of reading about those cool techniques and manually trying to deploy them in a Kubernetes cluster, why don't we try to formulate these techniques with policy documents, like you typically maybe have network policies and other kinds of policies, or, Governor policies. And then we have a tool like Koney that deploys them. So the policy document might look like this. We introduce a new custom resource definition here, where you can specify traps. For example, you want a trap in your file system. It's a file system honey token. You would specify where do you want to place it, what should the content be, which workloads do you want to match based on labels, namespaces, annotations, and so on. And very concretely, you can even specify on the technical level, how should we do this? I will show you later in the demo the concrete procedure how we're going to do this. So here we have container exec, and as a teaser, the monitoring of those traps we will then later do with Tetragon, which is powered by eBPF. So let's look at a brief live demo. This live demo will be composed of, we will work in 3 namespaces. The first namespace is the init namespace. You see this nicely. So I don't have anything running here yet. So let's deploy the init YAML, which is just a normal deployment. What is it saying here? Just an Nginx server doing nothing. And we do want to place traps in that one. By the way, you see it? Is it big enough? Yeah, see some thumbs up, thanks. So, and just that you believe me, I will show you the path here. At run secrets, currently we only have the service account. We don't have any traps yet. So the next thing that we're going to do is we are writing our deception policy. So we just have kind of deception policy, and the traps, we are going with, I hope I don't make any typos now. We're going with a file system honey token at the parse run secret AWS credentials. Maybe to make this quicker, here it is. Okay, so that's the full thing. We want this fake file content, and I want to have this policy applied to all my resources that have the Koney honey token labels set to true. So let's just save this and apply it. Yeah, I hope you not trust me that this is really live. And within a matter of seconds, if the demo goes with me, it's here now. So we have cd AWS, and here I'm already the attacker touching those credentials. And we're already coming to the next stage. I want to deploy another deployment. This time it's called scale. And the idea of scale is that we just spawn like, I think 20 pods, only to show that all of these also have the Koney honey token true label, just that you trust me that this is like live and works at scale. It's also going to run secrets. Oops. Still taking some time. In the meantime, I show you that this deception policy is also here. You can view it. You once again see the status, and interestingly, yeah, that's good. We already have like a deployment error here. So you also see, you can observe what kinds of traps are active. You could always disable them conveniently. Actually, I'm surprised. Why is the deployment error? Okay. I will just, in the meantime, try to remove it once. And reapply it. While I continue with my slides. Okay, so I first show you, maybe in the meantime, let's see if it stabilizes and it sets those traps. I will, in the meantime, show you how we do it. So when you write the deception policy, you give it to the API server, it stores it in there, which is convenient. And then Koney, which is an operator, triggers the so-called reconciliation process, which just is the API server telling Koney, hey, I got a new resource that you're supposed to own and handle. And with the container exec strategy, you guessed it, the thing that Koney is doing, it's looking for those resources and then placing that honey token just right now by executing cat. Also, it's setting up the monitoring for it. So just as a summary, Koney deploys it. It verifies also that it's there. It would also clean it up. We can try this later. And the cool thing is this is super transparent. Those traps are now not in a black box. They are really there. It works on the fly. You don't need to rebuild the images or anything. It should not interfere with any other kinds of stuff in the application. It's just a new file. It's just a process execution. We did not touch yet on monitoring because I want to show this to you now. So first, let's see if my trap is here. I'll first check the status. That's really unfortunate. Let's see if the trap is here in the init container. And I'm feeling lucky. I will now tail for logs from the Koney controller manager for the alerts container. And if I touch that file, there should be an alert here. Yeah, at least that is working. So you get this alert. We do this monitoring with eBPF, and you get your full alert showing which file was touched, which deception policy triggered that, which process was this, and so on. So the way we do this is with eBPF. I'm sure that there even was an eBPF talk already, so I will just skip this. It's a cool technology that makes the kernel programmable, as Liz Rice put it. It allows you to add certain functions to code in kernel. What we do specifically is we hook the so-called security file permission escape rope in kernel space. So this is a function that is checked whenever some file operation occurs, and they're checking if you even have permissions to do so. So this is convenient because when you have your application in user space, so even a shell that I had or some way, some process that an attacker might have in your pod, it will end up in kernel space when I'm trying to read the file. This could be an OpenSys call, but it could also be something else. So in kernel space, the kernel will check, is this user even having permissions to do that? So in here, we add our small eBPF program that also checks, is this actually the honey token that we have here? And if this is matching, this will go to a helper process in user space, stored in an eBPF met, and Koney will then pick up this signal again. Under the hood, we are not writing our eBPF programs ourselves yet. We are using Tetragon for that, which is a very convenient tool that you can have so-called tracing policies where I can just specify this with a simple resource definition. Exactly, like this is exactly the one that we have, and we see that here we are really looking at the security file permissions kprobe, and we're checking if this path is matching. Falco and Tracy, like they are doing similar things if you know them. Okay, I have one last demo. I hope now. Let me first delete some of my deployments again. Maybe let's also delete that one. Okay, just because I'm paranoid, I'll just restart the controller. So I'm going to run now a new deployment. And this is deployment secure. I can show you what it looks like. You see here that I have a config map for an Nginx server, also like a service. And I have a distroless Nginx container this time. Who knows of distroless images? That's good. So the idea with distroless images is that they only contain the necessary libraries and tools that you would need to execute, in this case Nginx, which has the downside that if I would go here and try to type S to open a shell, or let's do it like this, I would get an error because I don't have a shell process in there. So you remember we had our deception policy, and it had this strategy of doing container execution. So if I'm applying that now again, now I really expect an error. So let's see, for the deception policy, yeah, I have a decoy deployment error and I could not pull off the logs. It would tell me with this strategy I cannot do this because I don't have a shell there. Also, I have to still have a look at this container, I will just forward the port of the Nginx now. And I enabled index browsing here so that we have some way of looking into this container. And you also see now here in run, there's no secret. So there's no, our trap is not placed. But to still support this scenario, we do have another way of doing this, which is, you guessed it, the volume mounts. And I need to add one more thing here. Just give me a second. No, it's not this one. If the Koney will now do volume mounts, and I need to tell Koney that it is allowed to also mutate existing resources, because if we want to add a volume mount to a running deployment or pod, we need to restart it. So I'm just telling Koney it's okay, you're allowed to mutate existing resources. If you're familiar with Kubernetes, it's kind of the same strategy. So let's apply this again. And I should see my pod restarting. Yeah, if it just like 8 seconds ago, it's roughly at the time when I have the deployment, and now see if this is working. Oh, now I have run secrets. I don't have .aws because this is only because the directory listing includes hidden files. But if I browse directly to it, I still see the credentials here. And before clicking on it, I want to check one more thing. I also want to tail the logs again to see if also this access attempt via the browser will also be recognized. So let's look at credentials. Here they are. Let's look at this one. Here's our alert working nicely. In this time it was the Nginx process that accessed it. So this is all data that we get from Tetragon already. And what I also wanted to show you, you see here now in this deployment, yeah, you see it here, that Koney now adds a mount. So this is, I would say, the most stable solution then to add those Honeytokens, because it just uses native utilities of most container orchestration platforms anyways. And here it mounts also the run sequence AWS credentials from the Koney volume that we have here. It has the one downside though, this needs to restart the pods. Yeah, just to sum up, this case we are actually patching the deployment with the like the Nginx deployment here and adding a proper volume mount. Okay, so we had those two. This is the two techniques that Koney currently supports. There might be more in the future. If you want it at runtime quickly and easily, and if you have a shell, you can just do it with shell commands. Or if you want it more stable and also like in distroless containers, even less interfering, you can use also the volume mounts. But this, of course, will then need a brief restart. Yes, that brings me to the closing. So if you want to check it out, please go to GitHub. This is also the QR code that brings you there. Maybe give us a start. It helps a lot. And I want to reiterate on our vision as like we want to give especially developers or system operators a tool where they can quickly bring those ideas of having those small traps into production applications. As a quick outlook, we will also soon have something that does not rely on Tetragon. So where we instead has native eBPF programs. And today I only showed you traps for file system, but there will also soon be something for HTTP. So stay tuned for that. That wrapped up my talk. I talked about those deception policy documents, how we do this with container executions, how we monitor this with eBPF. And here again is the link. Thank you.
Amazing. So since we're very good in time, do we have any questions here? Yes.
Can you hear me?
Please take the mic for the recording.
Sorry, I don't see so well. Really interesting. But from what I saw is you all the files that you generate, for example, you define them manually, right?
Yes.
Is there like an idea or a plan to have some kind of automation to basically kind of randomly with an algorithm or hey, maybe even with an LLM in the future to generate some full secret files or whatever, or for example, some random endpoints, HTTP endpoints and so on?
Yes, very good. Thanks for the question. So if you have any ideas of helping you with those kind of files, so we do plan of soon have some sample files for most of the major tech stacks, maybe for some good traps for Java, some good traps for Node, so that they fit the environment, because then they're also really effective. I cannot tease too much about also generating them with GenAI. Works very well. So you can even if you give it the spec already today and just tell it, hey, replace this, generate this 10 times with some good names, it already works. But maybe there's a talk on that next year, where we also have that. Yes, thanks for the question.
Thank you.
Any further questions? Nobody? 3, 2, 1, none. All right. Thanks for being here.